Now, in this particular video, we're going to dive into a specific subscriber question that I came across in the comment section of one of our videos, and it states that we should determine the structure of this particular compound given right here, and this particular condensed formula of this compound and the suspected name. Now, right off the back, what you notice is that we notice a couple of charges here. That means that sodium atom must have lose an electron and giving that electron to this other species right here to actually create a negative charge on it. So once you're able to recognize that, it means that this particular compound, which we don't know the name yet, but we will recognize it based on the structure of the compound, we will be able to accomplish what the function it is right there. So first off, looking at this target compound with the R group possibly attached to a CH2, and the CH2 is attached to a carbon is attached to oxygen, and another oxygen with a negative charge right there. So based on this, we need to be able to take account the total valence electrons that are involved in bonding. Now first off, we know that an R group would contribute one valence electron to the overall compound structure. I'll just make this for A, and then our carbon, since we have two carbons, 1 and 2, then it means that we're going to have 4 times 2, which gives us 8 valence electrons, and then we have 2 hydrogens, which means that each hydrogen will contribute 1 electron, and in total 2 valence electrons. And finally we have 2 oxygens right here, and these 2 oxygens will contribute 6 times 2, which gives us 12 valence electrons. Now take note that since sodium actually donates 1 electron to this particular anion compound right here, we're going to put 1 electron from sodium in there, and that gives us an added valence electron to our anion compound. So for the total valence electron, which is our first step, we add 1 plus 8 plus 2 plus 12 plus 1. That gives us a total of 24 valence electrons. So this total number of electrons will be involved in not only bonding but also the lone pairs in this particular compound right here. So let's start off with, first let's look at the carbons, because carbons, they have the maximum unpaired valence electrons in their shell. So we know that carbon will come in, we'll probably have 2, because right here we have 2, and we have 4 electrons coming in there. We'll kind of differentiate one carbon compared to the other carbon. So once we have that, let's keep track of the number of electrons left. So we have 24 valence electrons, subtract 8 from 24, and what we're going to get is 16 electrons left. So this 16 electron left will be used in not only adding other substituents to that carbon but also create bonding. So this leads to the next point right here, which is surrounding 1 unpaired valence electron atom around this particular carbon. So the 1 valence electron atom we have includes the following: we have hydrogen, we have the R group right there. So what that means is that we're going to surround our carbons with the H atoms and the R group right there. So for the R group can be any form of alkyl groups, either X amount of carbon with hydrogens attached to them, and we're going to dive into that down the road. So now we've taken care of this first carbon here, which has total valence to be 4, and it's all occupied with the bond created with 2 hydrogens and 1 of the R group and the second carbon. And let's focus is how to stabilize this other carbon right there. So to stabilize this other carbon, which has now 3 unpaired valence electrons with oxygen. Focus on is the remaining electrons left. So we have 16 electrons. We subtract 3 from the 16 electrons, and what we get is 13 electrons left. The next step is to focus on the oxygens. Now we know that oxygens has 2 unpaired electrons, which has this specific structure like that, and this must actually fit in this particular carbon right here. So what that means is that to accomplish that, we need to take care of this carbon with 3 unpaired valence electrons, and since we're introducing oxygen, the oxygen will bring the 2 valence electrons, where one of the unpaired valence electron will bond with the carbon and the other one is left hanging. However, there's something that you notice in the carbon in focus. We see that this particular carbon has this electron still let loose, and it needs to actually be stable by forming a full octet. So to accomplish that, another one of these 2 oxygens, either oxygen 1 here, I'll put with a smiley face, or the one with this one right here, will actually contribute one of its electron or share its 1 electron with the carbon to form a double bond. So as a result of that, what we see is that our carbon in focus will have the 2 electrons shared with the oxygen at the top here, which contributes or shares its 2 electrons, and while this other oxygen right at the bottom, which is with a big smiley face on it, is going to share its electron with this carbon. So once we're able to accomplish that, let's keep track of the total electrons left, and right now we have 13 currently, but then what happens is that these 13 electrons in here, we're going to actually introduce 3 electrons from the oxygen, and that leaves us with 10 electrons left. So once you're able to accomplish that, our next goal is to be able to distribute the remaining 10 electrons around the most electronegative atom, which in this case is oxygen. So in this case, once we go back to the structure to distribute the remaining 10 electrons, which now becomes lone pairs on the oxygen, what we do is we just put it right here: 1 2 3 4 5 6 7 8 9 10. So once you're able to accomplish that, you notice that all the atoms here, they have a stable octet. They satisfy the octet rule by having 8 electrons around it, except that of hydrogen. So once we have that actually done, we keep track of the remaining electrons. We have 10 electrons, subtract from the 10 electrons left, and what we have is 0 electrons left. So this is actually the first step in concluding that yes, we have a definite structure that fits this particular compound. And finally, we actually consider the formal charge. Now the formal charge, we notice for hydrogen and R group and carbons, we notice that they are all 0 in terms of them having the satisfied number of bonds versus that of unshared and versus that of valence electrons for them to actually be neutral. However, for oxygen, we'll look at the first oxygen here with a smiley face, which is at the top here. What we notice is that the valence electrons on the oxygen is 6, and then we minus half of the number of electrons shared which in this case is 4, and then minus the number of electrons actually that is unshared, which are the lone pairs, which is 4. And what we have is 2 divided by 4 divided by 2 gives us 2, 6 minus 2, 4, and this gives us 0 right there. However, for this other one right here, which is the smiley face at the bottom, we have 6 electrons, and then you subtract or minus half of the shared, which is just 2, and then the remaining one is the unshared, which is around 6. So what we have is 6 minus 2 divided by 2 gives us 5. 5 minus 6 gives us minus 1. So the charge on this oxygen here is the negative. That is where it comes from. And then what we have as the structure is as follows. We have the R group bonding with carbon, which is what we have right here. This carbon is bonded with the carbon with a double bond on the oxygen. Don't forget your lone pairs. And then we have this carbon attached to this other oxygen with 3 lone pairs, and this has a negative charge on it. And we have our sodium with a positive charge. This here is actually having a carboxyl group that is kind of a conjugate base of the acid in a way, and in here we have the R group where the number of carbons actually in combination with this particular carbon star here actually gives us the name of this particular form of metallic salt right there. So that's about it for this particular video. Hope you're able to understand this. Please hit the comment down below, let me hear your thoughts, but that way I can talk to you all later. Stay smart and believe in yourselves.